Greetings everyone, my name is Manya Sharma and this is our operating systems project titled Security Vulnerability Detection Framework. This project is designed to stimulate, detect and demonstrate real-world OS level vulnerabilities in real time along with their detection signals and prevention techniques. So, what is the actual problem statement? In modern systems, vulnerabilities like buffer overflows, backdoors, and cache poisoning can compromise security. However, most learning resources are theoretical. So, me and my team built this framework to provide a hands-on, visual, and interactive way to understand how attacks work, how they are detected, and how they can be prevented. Now, let's move on to the overview of the dashboard. As you can see on the screen, this is the main dashboard. At the top, we have the key matrix, number of attacks stimulated, number of vulnerabilities detected, and the number of mitigations applied, and the current threat level. This gives a real-time overview of system security status. Now let's start with the buffer overflow attack. Here the memory layout is visualized showing normal data, user input, return address and overflow zone. When I simulate an overflow, the return address gets overwritten which can lead to code injection or execution hijacking. The system detects this and logs it as a critical event. We also provide prevention techniques like using bounded functions like strncpy, enabling stack canaries using ASLR. Next is trapdoor or backdoor attack. This demonstrates how hidden access can be inserted into a system to bypass authentication. Here you can see system layer interaction, which is from user to kernel to the hardware, running processes list, file integrity monitoring using SHA 256 hashes. If a malicious change occurs, the system flags it. We also stimulate detection tools like tripwire style integrity checks, hidden process detection. In the cache poisoning module, we stimulate DNS attacks. An attacker injects fake entries into the DNS cache, redirecting users to malicious servers. The system detects anomalies like mismatched IP addresses, suspicious TTL values, multiple DNS responses. Prevention techniques include DNSSEC, secure DNS protocols like DOH and DOT.
My name is Ratnesh Guleria, and this is my operating system project, a security vulnerability detection framework. This project stimulates real world vulnerability and demonstrates how they are detected and prevented in real time. For example, buffer overflow, cache poisoning, race conditions. To understand how the system responds to these threats, let's look at the alert logging system. All the detected events are recorded in the real-time alert log, which is right below the live terminal output. This includes the critical alerts, memory reset, and suggest mitigation techniques which are used to prevent the alerts. This helps in monitoring and incident response very quickly and fast. The project is built using HTML, CSS, and JavaScript for the front-end stimulated OS level logic for attack modeling, interactive UI for visualization. To conclude this, the framework helps in understanding real-world vulnerability, visualizing how attacks affect system, learning detection and prevention techniques. It can be extended further with real IDS integration. Also, machine learning based detection can be created and network level simulation can also be generated. Thank you everyone for watching. You can check the full project on GitHub using the link in the description. Feel free to give feedback or suggestions in the upgradation of the model.